Now, of course, there's a challenge here. I don't want to have to write mod is this and arg is this every time I want to describe a complex number in what we call polar form by giving the modulus an argument. I want a neater, more concise way. And it comes from just thinking about this. If this number up here is a plus bi, and this here is my modulus, r, well, a here is the same as r times cos theta. And b here is the same as r times sine theta. If you're not sure of that, write out what cos and sine are in terms of opposite and adjacent hypotenuse and convince yourself of that. It's important you get that right. A here is r cos theta, cos because it's adjacent. B is r sine theta, sine because it's opposite the angle. But in that case, I can rewrite a plus bi as, and in fact we do usually put the I first here, r cos theta for a plus r sine theta times I for the b part, for the complex part. That means it's r factored out times cos theta plus I sine theta. And what we do is we abbreviate cos theta plus I sine theta with a special abbreviation. And that special abbreviation is this, cis theta. It's a new piece of trigonometric abbreviation for you. Cis theta means cos theta plus I sine theta. So in Cartesian form, a plus ib or a plus bi is the same as in polar form r cis theta. So in polar form I have a very clear modulus and argument. And we have to learn to convert back and forth because there are going to be some times when you want Cartesian form, when you're adding and subtracting, it's easier to do it this way. And sometimes when you want polar form, when you're multiplying, it's often, or especially when you get to powers, it's often going to be easier to use polar form. Be careful when you're converting, as the textbook says here with a big warning. Your calculator won't necessarily give you the right answer just going b over a, because your calculator will always give you an answer in quadrants 1 and 4. But we need to work out where it is around the full circle. So always, always, always draw the diagram. Work out where you want it. Get the first quadrant acute angle and then add or subtract from pi or 0 to get the number you want, the angle you want.